Hi, this is Ask Brock. I'm Brock Yorty. This week's question comes from Kyle. Brock, I'm having solids loading issues in my solids control system. We have big solids coming off the Scalper, but my mud weight keeps going up. You know, this is pretty common, Kyle. Depending on the size of your solids control system, and we have a lot of mud recycling systems, big solids control systems. Let's just think about the smaller units right now. We have a scalping screen and we see all the big solids come off, and it's no different than if we were doing physical solids control and shoveling a pit, or we had an earthen pit and they're settling out. Big solids are easy for us to get out, right? It's our fine solids that kick our butt. So now we have that 300 gallons a minute going across the scalping screen. You got those big cuttings coming out. They should be, nickel to quarter size, half inch to 1 inch. Anything that's blowing apart at the bit face from your uphold velocity can be an issue. But then they go across the fine solid screen and the cones. And you got that 300 gallon a minute system going, and you have 2 5-inch cones, or maybe 3. So you have 75 gallons a minute per cone. So you have 150 gallons a minute, or maybe 225 gallons a minute of fine solids. And fine solids are what really hurt us. So you have that 150 gallons a minute of fine solids going across the screen that's designed to catch, 100 mesh, 100 mesh size cuttings. Think about when our mud engineers come out and they do a solids control, check for you. They're looking at mud weight, we're looking at viscosity, and then we do sand content, and that's a 74 micron is sand size, right? 200 mesh. So if you're not running a 200 mesh screen or finer, those solids, even though we're seeing those gelatinous balls come off on that low G energy shaker, it takes high G's to have a finer screen so that you can separate those solids from the fluid phase. So, you got that elliptical motion going and you got those balls falling off, but we still have solids falling through. So I'd go ahead and check to see what size screens you're running, depending on your system, and if it's elliptical or linear, is going to determine your fine, the fine size of your screens. So I'd look at that. I'd look at your uphold velocity for how the solids are breaking down. I'd look at your volume. If you have a 300 gallon a minute system and you're running 330 gallons a minute, you're overloading it. Look at the diameter of your hole. There's a lot of pieces we need there, but the most important thing is we really need to kick butt on fine solids. So if you have a 300 gallon a minute system, you need 300 gallons a minute of cleaning capacity for those cones. And those cones have to be able to go across the screen that's going to separate them all. So maybe grab a piece of plastic, blind off that top screen, and see if you have all of that underflow of those cones going on the ground if your mud weight starts to drop. There's a lot more pieces to this. Get your solids control manufacturer out there. Get a mud engineer, get the mud engineer out there first, get his recommendations, get her recommendations, then talk to your solids control company, discuss your cones, make sure you got apex nuts on those cones so that we're getting, the right type of effluent going across those screens. There's a lot of components there, but, we want to make sure we got good 75 gallons a minute at the right PSI, 32 PSI, or depending on what your manufacturer's cones, so that the cones are running properly. But we want to make sure that we're separating those fine solids. Big solids have always been easy for us to get out. That's not what makes a good solids control system. It's how we take care of those fine solids is what's going to help us. And those fine solids are abrasive, and they're what's really loading up. So good luck, Kyle, and let's hear some more information on this, and let's see if we can deep dive into this more.